Good evening to everyone joining from the India and Europe, and a warm good morning to those tuning in from the United States and around the world. I'm Shivam Srivastav, and it's a real pleasure to welcome you to today's panel discussion brought to you by the Center for Software and IT Management at IIM Bangalore. Our topic today is when AI joins a product team, then who really drives the innovation? It is a question that couldn't be more relevant now. And as an artificial intelligence becomes a key player in product development and strategic decision making, we are seeing that it generates insight, propose solution, and handle the tasks that used to rely entirely on the human judgment. But this shift also raises an important question that when human and machine can collaborate, who's really steering the innovation? And how do we make sure that the data driven decisions work hand in hand with human creativity, intuition, and a vision? So, to help us unpack these issues, we have an outstanding panel with expertise spanning computer science, philosophy, data science, and industry leadership. Together, they will explore how AI is transforming the way work is structured, how we distinguished between judgment and execution, and what it truly means to innovate responsibly in this new era. So, our panel will explore some of the very pressing challenges shaping the future of innovation. We will discuss the ethical reasoning in AI driven environment, the accountability in human AI collaboration, and how strategic thinking is evolving in a world where automation can deliver impressive results, often without transparent reasoning. Today's discussion isn't just a theoretical one, it holds valuable insights for academics, policymakers, and industry leaders alike. And we will explore how organization can tap into the full potential of AI while ensuring the human creativity, judgment, and ethical responsibility remain at the core of innovation. So before we begin our panel discussion, I'd like to invite Mr. Venkatesh to share a brief overview of the center's ongoing initiatives and activities.
Sure, Shivam. Good morning, good afternoon, and good evening. I'm Venkatesh. I manage the Center for Software and Information Technology Management of IIM Bangalore. On behalf of IIM Bangalore and the center, I extend a warm welcome to the distinguished speakers of today and all the participants. In fact, we should mention that we are honored to have Professor Anand Rao, Professor David Danks, and Professor Rishit Bishnoi as panelists today. For those of you who are joining our program for the first time, I would give a brief introduction. This center is IIM Bangalore's Center of Excellence for Digital Technology Management, and this has been in existence for about 25 years. And Bangalore being the IT hub of India, it gives us a local advantage, and we have a huge network of researchers, industry leaders, and lawmakers. And our goals are aligned to promoting knowledge sharing, training, and research. And we conduct various events. Some of them are in the format of webinars such as this. And this particular session is of great importance to us because we are just getting ready for a software product management summit, which is going to be the 8th edition of this. And we conduct workshops which do a lot of deep dive into technology areas and for skills development and everything. And we are in social media, particularly in LinkedIn, and we would request all the participants to follow us through our communication through mail and also particularly through LinkedIn posts and take part in all our events for the Software Product Management Summit. I would say that all the participants can nominate themselves as paper presenters, speakers, or nominate their products for excellence awards. And for the students, there is a student case competition. And in fact, all the other events in the form of workshops and other webinars are also of importance to all the students, researchers, and professionals. And looking forward to seeing you around in our future events. And with that said, I hand it back to Shivam to take today's event forward. Over to you, Shivam.
Yeah. Thank you very much, sir, for sharing these. And it's now my pleasure to introduce our distinguished speakers with us. So our first speaker is Professor Anand Rao. He's a distinguished service professor of applied data science and AI at the Carnegie Mellon University's Heinz College. His work lies at the intersection of artificial intelligence, data-driven policy, and strategic innovation. Before joining Carnegie Mellon, Professor Rao served as the global AI lead at PwC, where he advised Fortune 500 companies and the government on AI strategy, responsible AI practices, and effective implementation. His current research centered on the operationalizing AI systems responsibly and ensuring that they meet the highest standards of reliability, safety, and the governance in both public and private sector applications. Professor Rao has co-edited 5 books and authored numerous academic and industry publications on AI safety, agent-based modeling, and the economics of innovation. He's also deeply engaged in global policy discussions and AI regulation on governance, contributing to initiatives by the OECD, the World Economic Forum, and the NIST AI Risk Management Framework. Our second speaker is Dr. David Danks. He is currently a professor of data science and philosophy and policy at the University of California, San Diego. And starting this January next year, he will be taking a role as a Polk JSF Distinguished University Professor of Philosophy, AI, and Data Science at the University of Virginia. Dr. Dang's research covers the ethical, psychological, and policy aspects of AI and robotics across the various sectors. Alongside his work on policy and ethics, he develops novel AI systems and computational cognitive models, connecting theory with the practical application. He was an inaugural member of the US National AI Advisory Committee and now serves on multiple advisory boards in industry, government, and academia, contributing to the development of responsible AI practices worldwide. Our third speaker is Professor Nishit K. Vishnoi. He is a professor of computer science at the Yale University, and his research lies at the intersection of algorithms, optimization, machine learning, and society. He is a co-principal investigator of the $20 million NSF-funded AI Institute for Learning-Enabled Optimization at Scale, which is known as TLOS. Professor Vishnoi's work spans both the theoretical and societal dimensions of artificial intelligence, and he particularly addressed topics such as efficiency, fairness, and the evolving nature of the intelligence. He is also a fellow of ACM and the American Mathematical Society and has received several Best Paper awards recognizing his contribution to the computer science and AI research. He is also the author of the Intelligence Loop, a Substack series that examines AI from both computational and philosophical perspective, and the book Algorithm for Convex Optimization, which was published by the Cambridge University Press. So once again, a warm welcome to everyone joining us today. It is truly an honor to have such a distinguished and diverse panel with us today. Let me just briefly walk you through the structure for today's discussion. Each of our panelists will share their perspective for almost 15 minutes. And following to that, we will have an interactive discussion among the panelists. And toward the end, we will open the floor for the question from the audience. So feel free to type in question as and when they occur to you. I will collect them and we'll involve that into the panel discussion. The sequence of today's panel discussion is Dr. Anand Rao, Dr. David Danks, and Professor Nishit Vishnoi. So without any further ado, it is my great pleasure to invite Dr. Anand Rao to share his insights with us. Over to you, Dr. Rao.
Thank you, Shivam, for inviting me and having me here. And thanks to IIM as well. So without going further, let me just sort of introduce the topic here. So when AI joins the product team, who really drives innovation? As as Shivam said, I'll be approaching it both from a corporate perspective as well as academic perspective. But more importantly, I think given my backgrounds, I've been in AI for almost 40 years now. Around 15 years of that in industry research, then more on the commercial side, went into consulting for a variety of different companies. So bringing in that perspective of what really happens in the business world. And then over the past couple of years back as an academic, right? So, and seeing some of the things that are happening there. So I'll try to weave in all of that and also hopefully set the stage for Professor Danks and Professor Vishnoi to come in as well at the next stage. So obviously, this is the topic here, but I wanted to look at decision rights, metrics, and guardrails for AI-driven innovation. So specifically looking at AI joining the product team and also focusing on who is really driving innovation. So innovation is the key word. Again, driving is something that wanted to look at. Couple of recent happenings, right? So which I'm sure some of you have been closely following the industry would know, but others are probably aware of it. Anthropic recently introduced their Claude model. And what is interesting about that model, this is the code development model, it can go non-stop without having any human intervention for 30 hours. So think of your best mind just of going off and doing the coding and the development without asking any questions nonstop for 30 hours. What Anthropic typically does is they actually have the new AIs recreate Claude.ai. And this one, I think, was sort of recreating Slack and spending 30 hours doing it nonstop with no human interaction, just wanting to give the sense of what is happening. And then also it's happening very fast, as we all know, but some of the caveats on just sort of stepping back and looking at the broader picture. So that's what I'll look at when we look at the product team. Of course, we see that, and then something around the coding and the algorithmic side as well. In the recent competition, which is the International Collegiate Programming Contest, where teams from across the world, from universities, compete on a hackathon or a programming contest. And in the recent one, both OpenAI and Google actually successfully completed to a gold medal status. OpenAI, with their existing models, completed 11 out of the 12 questions. With their new yet to be released model, they completed all 12. Google, I think it was around 11 or so. So again, getting to that expertise level in coding, Math Olympiad, and a number of things that we have seen, but this is fairly recent. As you see here, it was, I think, between 31st August and 5th September. And these systems are there, so I'll come back to the product development side. So I'm still looking very much at product development in the coding side. Again, there are a number of these systems. These are agentic large language models, multi-agent systems. Just to give you a sense of end-to-end what they do, here is, again, one of the papers, right? So there are many of these, right? So not trying to single this one out, but there are many papers that look at essentially going after the end-to-end software development life cycles, not just the coding piece. And in fact, some of the successes have been doing this end-to-end. Here you're seeing very much the requirements process. That's one of the more challenging processes. How do we actually get to the requirements? And of course, from the requirements coming to the architecture, the design of it, the architecture of it, and then the coding, testing, and deploying any sort of standard software development life cycle. And you can see here how for each one of the human aspects, so different stakeholders, different personas who will be using the software, there's a system that's actually the large language models. These are all multiple agents, with each agent being a large language model, essentially going and conversing with each other and developing the user stories. From that, you are extracting requirements. You're going and finding other similar kinds of software that have been built, coming up with the UI, UX, the user interface, user experience. All of this are being done by multiple agents. Whatever we do as people, you're essentially seeing this pattern. You're mimic that with these large language models with a whole amount of data and reasoning associated with it. These are not pure large language models. They're large language models combined with systems that have existed in the past, in the 80s and 90s, when we used to work on planning, in reasoning, common sense reasoning. Many of those techniques are coming back, but within the LLM or the large language model arena. So it's just one example of these are existing systems. As you can see, this is actually a one-year-old paper. One-year-old papers in this field is pretty ancient. So it's not just that where you're doing at the software level end to end. Now, just recently, again, this is very recent news. So September 30th, as you can see, Periodic Labs came out of a thing and announced their 300 million funding. And what they are working on is something called an AI scientist. It's not just them, it is a whole host of groups that are working on an AI scientist. Most of you would have used Deep Search. That's very common now in the platform, which did not exist, in fact, 1 year back, but now it is commonplace in many of the tools that you are using. Now people are working around an AI scientist in the sense of generating hypotheses and actually executing them. And you can see here the recent announcement around Periodic Labs, again, by ex-Meta and ex-OpenAI execs starting this with some substantial funding there, essentially looking at a closed loop, what is now being called as self-driving labs, right? So we'll come back to this thing. There are lofty visions, and what is interesting about these are closed loop labs that are attracting mega funding. The reason for this is this what is called as the data flywheel, right? So once you start entering an area, start getting more information, which basically means that once you have a starting system, which does, again, decently, may not be the best, there are more users that get attracted to it. When you get more users, you start getting more data. And if you look at the coding environment and what people have done there, there's enormous amount of code that people are leveraging in order to build better code. So it can essentially self-adapt or reason, right? So it essentially critiques itself, tests it, and keeps doing that cycle. And that's how the Claude that I just mentioned earlier has been going for 30 hours, where it does it modularly and it sort of critiques itself, tests it, and comes back and changes, critiques it for performance, critiques it for functionality, and a whole host of other things. So this value creating works only when these loops have been validated, and it actually does get better. Only then you really have the value. So I want to connect it back to which of these things would succeed and which of these things fail. Now, of course, come back to the main question here: are we ready to let AI join product teams? Again, whether we are ready or not, I think it is happening is the other one. The question more for, I think, many of us is, how should we let this happen? Can we try and do it in a more responsible manner? And this is where, yes, I think AI is already entering product teams, just with a few examples and a few more that you'll see later. But at least my leaning towards this is it needs to be brought in more as an augmented to the humans, so that we can guide it, we can drive it, as opposed to the system driving its own, right? So there's obvious advantages of what the system can do, but we'll come back to some of the disadvantages of AI. So I would very much recommend augmented or hybrid human plus AI working as product teams, not just one. And then we are essentially looking, are we ready to let AI drive innovation? I would say exercise a lot of caution. Look into the notion of autonomy and what I call as budgeted autonomy. So give it a little bit, see how it performs, and then make sure that you always have the skill switch. Again, creating something like a kill switch is also not an easy thing, right? So again, I'm sure we'll get into some of these issues, but I don't think it's a question of are we ready or will or when the AI is joining the product team. AI is already there, part of the product team. The recent SDK that OpenAI announced is essentially integrated with Slack. So if you're a programmer developing stuff on Slack, instead of one of your programmers, you have OpenAI Codex essentially becoming that coder. So it is sort of participating in discussions, and it's taking instructions and actually executing them. So that's the way it's currently working in that augmented mode. Now, there's essentially a variety or a spectrum of things that are emerging here, what are called self-driving labs, where you're seeing this closed loop. And now I'm moving from software development into scientific arenas like biology and chemistry, where the AI is now working as a scientist. And when I say it's working as a scientist, it is coming up with the hypotheses. This hypothesis sometimes are validated by humans, sometimes not, but then it actually goes and executes it. It does sequencing, it does perform experiments in the lab, gets the data, feeds it back. So there are these self-driving labs, 24/7 labs. And what they are aiming to do is to accelerate the way the experiments are developed and also enhance the performance, right? So there's a quick chart there which shows that the reference point being the human advances, whereas how AI is improving the performance and also reducing the time, both by the 24/7 nature, but also as an exhaustiveness in which it is doing that analysis. So given the time, I'm going to go a little bit faster here. And so that there's those things exist for, obviously, we looked at from software, we looked at biology, and it's also there for material science is another example here from Google. It's a graph network for material exploration or genome, which essentially came up with 2.2 million predictions of different materials, and then 380,000 of them are stable materials that it has essentially synthesized, predicted, and then synthesized. And this is compared to roughly 48,000 that humanity has produced over the past whatever number of centuries, right? So again, all this has happened in a very relatively short span. Everyone is aware of AlphaFold and the things that have happened in the biology. Now you're seeing that in the material science, you're seeing that in chemistry, not just one university. There are multiple universities, multiple companies that are doing that. So essentially taking over. I said these are labs which are self-driving labs. Now, there is a contrast, right? There's a spectrum, as I said, but people are also building AI co-scientists. So co-scientists is something which is an hybrid approach. And then, of course, driving labs are completely autonomous. My preference is then there's a spectrum in between in how much of involvement humans have in this. I err more towards the co-scientist role. Again, examples here where the AI is generating, it is good at actually going and grabbing information, and it's getting much better at being much more nuanced in the way it picks up this and actually generate these hypotheses, which can then be debated, validated by the humans, and then gone on to do the experiment. Again, this is another article here which talks about the AI co-scientist and how it's being developed. This is from Google and Google DeepMind. Another slide here where you can do a variety of different things, very much from a basic research all the way to an applied area. Won't go into the details, but there are very specific ways in which it is coming up with the hypotheses and then testing it. And then based on the test with reinforcement learning and other mechanisms, it's correcting its own hypothesis generation method and gets better at it, right? So it evaluates itself. It evaluates from the external world. There are things called inner loop and outer loop. So it'll debate it with itself and self-evaluate, and then it'll try something externally, and then it'll incorporate that. So the external trying would be with the humans, with the environment, and so on. So there's a rich environment that is coming up for all of these. So this all looks great, right? So you say, this is great. We are basically in the era of AI getting into product development from end to end. Doesn't matter whether it's software or other kinds of more physical products, biology products, physical products. So should we just hand the keys to the AI? Before we do that, I'm just going to do sort of three things, and I'll stop here, Shubham. 3 points to consider here. Now, the AI has what's called a jagged intelligence. In other words, it's very good in some things, but it's also very bad and terrible, worse than a 3-year-old or a 5-year-old on a few things, right? So, and this is what was shown in a relatively older one, it's sort of at least 2 years now, where Harvard Business School and done an extensive study with BCG and in the consulting arena, where they picked up creative situations as well as more traditional cognitive problem-solving issues. And you can see there that the business problem solving, actually we're using GPT-4 at that time, was good for in certain cases, but not very good, right? So for business problem solving for certain areas, the performance was 23% lower. On the creative side, on the average, it was better, but interestingly, it was the performance of your best creative people actually came down. It's also reverting to the mean. It is raising the people who are less skilled to a higher level. At the same time, it is almost disempowering, if you like, your brightest minds and then bringing them down. So there are some interesting things that are happening. So we need to be careful on trusting these machines to do everything. We need to see for what they are good at, for what humans are good at, to come up with this hybrid. So that's the key message here. So let's try and understand. There's a lot of work here, which we don't have the time to go into, but then also gate the autonomy, right? So when and how, only when you feel very confident. We'll come back to the trust notion next, but you need to give it certain autonomy, see how it performs, and then withdraw. I think good managers do that. They know how to have and mentor younger graduates who come in. So give them the autonomy, see what they are doing, but be there closely watching them so that you can guide them. And as they get better, obviously they're given more empowerment, and then obviously they grow on to become more senior leaders in a company. And that's what we do with people. And I'm claiming that that's what we need to do with the AI. So we just can't trust them now and say, hey, they're great, and let's just get them to do things. AI as a trust problem. We all know that, right? So the problem is it does some things very well, and therefore we start trusting it, but then it does some things terribly, and we are surprised when it does something terribly. And I think we shouldn't be surprised. We should know that it's not going to do certain things well, and that's why we need to know when to trust the AI and when not to trust the AI. And that's something that's, again, well researched in the academic world, right? So what really engenders trust? The integrity, the ability of it, right? So again, there are some shortcomings in the ability of the large language models, as we know, some of the hallucination issues, which the academic world is trying to fix, but you still need to look at the ability, the integrity, and also overall, how does it perform? What is the values that you are going to give to it? Again, there's a whole host of things that a number of people have talked about in terms of value. What values does your AI have? Again, these are not theoretical, philosophical issues. These are real issues that need to be tackled now as to what is the value and what is the value that the AI has. What is your company value? Does your AI have your company value, the individual value? How does it all come together? As some of these tools have now started looking at memory and then trying to encode what a certain person is doing, you need to be careful as to how this notion of trust embodies. So again, a solution to that, so clarify the ownership. So who within the organization is using it, for when, right? So and where and how the AI is using it. Which human has control over which aspects of it? If you take it standard software development as a product manager or any of the others, right? So have a very detailed understanding of the process that we are going through, where AI is stepping in, and where the human is controlling it, which human is controlling it, for what reasons, how, and so on, and the escalation method, right? So the whole notion to build that trust across the board on different parts of the machine. So that's the one. And then lastly, the other one that we also need to worry about, which I know as companies, people don't spend too much time, it's what's the societal impact. So there's sort of evidence coming through. So this is a paper by Eric Brynjolfsson and a couple of other folks at Stanford, essentially showing the impact of what AI plus other things, but I would say largely AI has had on the job prospects, which we obviously are seeing, but this is sort of economic evidence to it. the blue line that you see dipping, that is actually early career, 22 to 25-year-olds. Their job prospects have diminished significantly, especially in white collar areas, right? So like software development. And you have this sort of famous quote by Dario Amodei, who is the Anthropic CEO, talking that 10 to 20% spike in unemployment. And that is already happening in US, especially at the entry-level jobs. We see that in the universities. And this is something, yes, we are trying to get efficiency on one side, but do we want to really disempower a whole cohort of bright minds that we have, and what consequences that would have? So that also, I think, should be taken into account as we think through as to who drives this push towards AI in the innovation and AI in the product management cycle. Who's making the calls? Who is deciding? Who decides how it needs to be decided, right? So I think if those of you who read Shoshana Zuboff's book, right? So on surveillance capitalism. So she talks about who decides, right? So the second level decision, that becomes very important, not letting just the tech industry drive the agenda on what is good, what is bad, but have a much larger involvement of groups. So that's why I think I would like to cue it for the panel as to who decides when to ship, not to ship, who decides what extent AI should be involved in all of those. And that, I argue, should be us as people at different levels. So with that, I'll close, and I've taken a couple of minutes more. Close here with clarify the decision rights. So run on the evidence, not on the vibes, and budget the AI autonomy. And trust is an important factor, and trust needs to be built. I call it trust management. So trust has to be managed. It just can't be defined and said, you're building trustworthy AI, therefore people will trust it. You need to make sure that the people can trust it, trust the AI. So that's where I think we need to focus our attention. Let me stop here. Thank you. Thank you, Shiva. I'll just stop sharing.
Yeah. Thank you so much, Dr. Rao, for your inspiring presentation, if I may put that. And your talk really helped us to understand the several concepts, such as the augmented hybrid setting, that we may focus on the multi-agent LLMs for requirement, and given a sense that, like, how AI can transform the way organization plan and make decision and handle the challenges. And I especially like the idea that about, like, this concept of augmented and hybrid, where we are blending human judgment with the AI insights and the learning continuously from the data and adjusting strategies as the situation changes. So it was also very helpful and useful to see that, how organizations can apply these approaches to stay resilient and make smart decisions. So now I am pleased to introduce our next speaker, Dr. David Danks, to share his insights with us. Over to you, Dr. Danks.
Thank you so much, Shivam. And thank you, Anand, for setting things up in such a wonderful way. I think that it hopefully will flow smoothly into some of the observations that I was hoping to make today. I think one of the challenges that sometimes happens when we think about these tools is that on the one hand, we can do the philosophical move and go to too high of a level. Other times we can be so caught up in the details of a particular system that we can kind of lose sight of some of the broader issues that I think Anand was raising at the end of his presentation. And I want to start with and actually center my remarks around a kind of what might seem like a simple observation or simple question that turns out to be incredibly complex, which is, how should we think about the relationship between those values that Anand was talking about, especially towards the end of his presentation, and the technologies that we build? Not only AI, but actually all of the technology that we're using, whether in our business settings, in professional settings, in personal settings, and the like. And I think that there's a very common view. I suspect some of you, just statistically, some of you on this webinar probably hold this view, that technology, they're just tools. If we think about something like a hammer, the hammer, when we think about values, that sort of doesn't make sense, right? It isn't that the hammer has values. The hammer is just a hammer. It's a piece of, say, wood and steel. And I think similarly, people often think that way about AI. That there is a widespread view that AI, it's just ones and zeros. Now, maybe there are complex, becoming self-aware AIs. I personally do not think that that's right, but if you think that there are, then you might say, well, okay, those systems might embody or have certain values. But I think that it's often framed as there's a problem. I develop a tool to help me solve the problem. I have to worry about how the humans interact with that tool. It wouldn't work very well to have a hammer that, the handle of the hammer is this big around, because then no human could actually hold it, right? We have to think about human factors and all these things that we've been worrying about for decades, if not centuries. But I think the common view says, but the tool itself, the technology itself, the AI itself, it is value neutral. Okay, I think that's a common view. It shows up with sort of professional obligations and issues of professional ethics when people will say, "Look, it's not my job as an AI engineer to figure out what kind of technology is needed. It's my job just to produce whatever I'm told to produce." Much as somebody who focuses on bridge building might say, "It's not my job to decide where we put the bridges. That's a policymaker's job. My job is just to build bridges that don't fall down." I think we're seeing already in the AI field a lot of people who say it's not my job to decide what kind of AI we build. Somebody above me in the food chain in my organization is going to tell me that. And I think that that sort of mindset, the mindset that says I'm just coding, I'm just building ones and zeros, I think misunderstands fundamentally the role of technology in shaping values, but also the ways in which our values are embodied and embedded in those technologies. Right? Because if you adopt the common view, then all the stuff that I'm about to say about ethics and those kinds of things, you will think that only matters for the use of it. So I can build Gemini or Claude or Llama or whatever it may be, and on this common view, there are no ethical decisions that I have to make. The ethical decisions on this common view show up only once I've shipped, and they show up only for other people. And I think this is particularly something that we need to be thinking about as we think about issues of design, because one of the insights of designing and design methodologies and design practices is that value-based choices are everywhere when we're doing design. And because we don't know how to build certain kinds of AI systems, we're inevitably making a large number of design choices. One of the things that I do with the undergraduate and graduate students that I teach is we will typically, early in a class, in a course, we will have a class where I'll say, let's imagine we want an AI system to, I don't know, predict student success. So I know which students are going to need help in my class. This seems like something that we would want. The students would want to be able to know how likely they are to succeed in a class, how likely they are to get a good grade. Seems like a completely straightforward AI data science problem. We've got huge amounts of data from past students. Let's just throw it into the AI and let's go. And what I do with the students is I say, okay, for this idea, let's figure out all the questions we would need to ask in order to actually build such a system. We have to ask, well, where are we getting the data from? Which data are we going to use? How are we going to define success for students and these kinds of things? And we will go through this and we'll end up with 27 questions or things that we need to resolve on the board. And then the question for the students is, how many of those are dictated solely by the math? How many of those really are just about the ones and zeros? And the answer is usually one, maybe two of those 27 questions. For all of the others, you can look at it and think, well, I could do it this way or I could do it that way. And those are the points where ethics and value come into design. When you have freedom in how you design, when you have freedom in what you design, when you have freedom in how you build something, when you have freedom in what you take to be success, those are all places that ethics and values are coming in, because you as the designer, you as the developer, are making decisions about, for example, whose problems should we bother to address? Right. So think about the AI scientists that were in announced talk. Okay, but which scientific problems are worth solving? I mean, there's a scientific problem that is how many penguins are on this particular iceberg off the coast of Antarctica right now? That's a scientific problem. I don't personally think we should be investing AI resources in trying to answer it. But that's a value judgment by me. I mean, maybe somebody else thinks that that's a really important question. And so when we think about what we're going to build in the first place, already we're bringing in values and ethics. When we think about what counts as success, go back to that, system to predict student success. But is student success they get a good grade in my class? Is it that they graduate successfully? Is it that they become better people? Is it that they make a lot of money when they graduate? For a lot of students, that's probably very high on the list of things that matter for their success to them. Well, as we all know, when you build AI systems, you have to specify a loss function. If you're doing standard optimization, we have to tell the system, here's what you're trying to achieve. But that just is to say, this kind of success is more important than that kind of success. Because if I build a system that will predict which students are going to make a lot of money after they graduate from UC San Diego, well, then I'm going to look and say, all right, I'm going to tailor my teaching to the students who perhaps wouldn't make as much money. But that's going to be a very different approach to teaching than if I'm going to be tailoring my teaching to the students who might fail my class. Right? I'm going to do different things because of this. So it really matters that we figure out what counts as success. It matters how we resolve trade-offs. We can never do everything we want in a system, even despite some of the hype that comes from the AI companies. There's always trade-offs when we're building and using these systems. We can't have a system that is low power consumption, fast, reliable, and solves every problem we want. Right? You have to pick which of these things you want. Do you want a high power system in terms of its capabilities? Well, it's probably going to be high power in terms of electricity and power consumption. Right? So we have to think through these trade-offs. And right now, the reality is almost all of these decisions are being made by humans. They're made by humans often who don't realize they're making the decision. They'll just go, well, let's just do things this way and we'll figure it out later. Right? A lot of times the decisions that go into the design of an AI system are, quite frankly, not done intentionally enough. I think that was another message that came through towards the end of Anand's talk, is the importance of being very intentional about what values we want to see in our technologies. But nonetheless, when we think about these things, they are being done, and they're being done by humans, not by AI. So, of course, the question is, what happens when that changes? When we bring the AI into the design loop? Well, obviously, the AI designers are then going to be ones shaping the values of the technology. Those AI co-scientists are going to be selecting some problems as more important to study than others. They're going to produce vaccines or pharmaceutical agents for some diseases, but not others. They're going to decide whether they should build the next version of Claude or they should replicate Claude.ai in ways that support better understanding and more factual outputs to various prompts, or they're going to have to decide whether they want something that just makes people happy and exhibits all of the standard sycophancy that we come to expect and some of us hate when it comes to these kinds of systems. So if AI designers are going to shape the values, then we actually have to ask a kind of second order question. Right? We have to ask, what are the values that these AI designers are going to prioritize? That is, what are the values for their values? It's sort of like who decides who decides. Well, whose values shape which values the AI systems are going to try to put into the technologies that they're helping to design. These are not questions that anyone is openly asking right now. These are not things that we actually know. When we look at the specifications of some of these AI design tools that are being provided, the place where I've looked more is in AI design tools in architecture and planning buildings. If you ask, what values does this design tool, does this design system, this design AI, what values is it promoting? The people who build the systems can't tell you that, which seems to me a problematic state of affairs. Once we know what these AI designers are prioritizing, we can then ask, how do we change and shape those? Right? Whether it's through regulation or policy or governance, whether it's through the users of these tools, the humans who are cooperating and collaborating with the AI systems, we can start to ask how we might be able to change and shape those values so that our human intent can actually be realized through the technologies that we construct using AI design assistance. And so, if AI is actually going to be the kind of partner that I think a lot of people want, and that was uh, suggested by a lot of the slides that Anand was showing us, if AI is really going to be a partner, we need to know something about our partner. We might need to shape what our partner does. Think about if you've ever mentored somebody on a task, whether it's a graduate student or an undergraduate student or somebody in a company. When you mentor people, part of what you're doing is you're shaping their values. You're getting them to understand, here's how we do things in our company. But how do you do that to an AI? How do you shape the values of an AI? Because that's going to be absolutely critical if we want to have the kinds of trust that are needed for these systems. More generally, how even should the human designers engage with these AIs? Should they simply outsource certain details? They give this, they give it almost like a kind of prompt engineering. I give the specs, and then the AI produces the design for me. And then the question is just, does the AI faithfully honor the values and needs that I express in my design constraints? Or is it a more dynamic and interactive process? Is it one where we are kind of almost more the way that, for example, a lot of students now use generative AI, large language models, when writing papers, which is it's not that they ask the system to write the paper for them, it's that they're constantly interacting with it to try and co-construct the paper. Um, I wish that I could sit here and tell you that we know the answers to all of these questions. The reality is we don't. These systems are evolving fast. They are showing up quickly. They are coming into practice faster than we are able to understand what it is that we're bringing into the design process. It's an area where I think we are starting to make some progress. But I say this as a kind of cautionary note. There's a lot of hype out there that AI is going to transform the design process, that AI will be the accelerator to, or the catalyst to mean that your company is going to be able to innovate 5x faster than everybody else. The problem is we don't actually have any clue whether those claims are true. The companies want you to believe that they're true, of course, but we don't actually have very good evidence. And most of the evidence that we're getting is like the green and red bar chart that you were seeing from Anand, which of course focused on um, uh, BCG employees, but we're finding this actually across a whole bunch of different sectors. That AI helps in some ways, it hurts in others. It helps some people, it hurts others. And so I think it's important for us not to stop using these systems, not to ban these systems, but rather to recognize that we're moving into a space where we don't have all of the answers already. We don't know how to do things properly. And so we need to be thoughtful, cautious, and intentional about not only when we use AI, but what AI systems we're using at all when it comes to design. So I'll stop there, hopefully having not been too pessimistic here on a Friday evening for all of you. And I look forward to the panel discussion. Shivam,
Yeah.
back to you.
Yeah, thank you so much, Dr. Danks, for your presentation. Your work illustrates us that how design choices shape the ethical, social, and psychological values that have been embedded into the AI system. We also, get the sense that as AI becomes an active participant in design processes, we must be intentional about the values that you talked about, how it embodies and promotes. And you've also raised an important point about the managerial and human skills needed to be collaborate effectively with the AI designers as an essential consideration for the teams, those who are integrating the AI into their decision making. So thank you so much, Professor Danks, for your presentation. With that note, it is my pleasure to invite Professor Nishit Vishnoi to continue the discussion. Over to you, Dr. Vishnu. Yeah, Prof, you're on mute. Yeah.
All right. Okay, thank you everyone for the invitation, and thanks to Anand and David for setting up the stage and making very important points, which I agree with. In this talk, however, I'll take a little bit of a more, I would say, slightly more mathematical angle in trying to understand, given that we are quote unquote forced to live in, with these companions, whether we agree with their values or not, how to best go about doing it. There are so many places where I can, I have so many thoughts coming, following up on David and Anand, but maybe we'll get to talk about it in the panel. But let's talk about how to make these decisions. Okay, so the setup or the starting point of this talk is various news articles. You've seen many of them, so I'm not going to spend a lot of time on this. But there is a narrative, there is a hype, there is some reality to it, maybe, that AI is going to take away our jobs. And in particular, Dario Amodei, who's the CEO of Anthropic, a bit more than 6 months ago, predicted something about what is going to happen now. Clearly, it hasn't happened. So the question becomes, how do we assess the real impact of AI on work? What are these predictions based on? Well, some of the predictions are based on narratives created by corporations, but there are also some good faith actors who are looking at adoption data and other labor data and trying to fit in, curves onto what they're observing. There are some other folks as well who are actually looking into, and I think Anand mentioned the study, or at least by the same authors, who are looking at it more empirically, trying to understand at an empirical level what exactly does AI do in these environments where it works along with humans. And in particular, some of the observations that have been shown is that generative AI boosts productivity, especially for junior workers. And I think this is consistent with their later work, which Anand cited, which talks about how the employment opportunities for junior workers is going down, because that's where the maximum gain is in some sense as well. So there are many such studies, and the question that is missing, or what seems to be missing, is a model, a rigorous model to understand and predict work in the age of AI. So before I kind of give you a sense of what this model looks like at a high level, let's look at what the current state of the art, roughly speaking, is in terms of how do we understand jobs, how do we understand evaluation. And when you're thinking of this, don't think of your own job. I think of a big corporation, like for example, in India, we have the Tata Consultancy Services or IBM, like big corporations where there are many, many jobs which have some description. There are workers who are doing that job, and then some kind of evaluation keeps happening to understand whether a job work, to what extent is the job worker fit good. So let's look at that. And I think for this talk, I'm going to use an example from this database, which is called OStarNet. If you haven't seen it, you can go and take a look at it. It's a comprehensive database maintained by the US Department of Labor, which provides descriptions in English of a lot of jobs. And here is one example for you, computer programmers, which is what the panelists before me have talked about. And here you can take a look. I cannot display the whole thing, but you can look what the description looks like. So there are some tasks, some skills, vaguely defined, some importance associated to these skills and tasks. Usually, this is not a new data set or new database, but usually it feels insufficient or underspecified for for what we want to use it today for. And in particular, it lacks a structure. So how do tasks depend on skill and so on? And moreover, how do we evaluate performance? How do we, at the levels of skill, tasks, and jobs? So this stuff is really not specified. So this is in the world of job specification. Evaluations are also not so here we're talking about human evaluations, and in the next chart, I'm going to show you about AI evaluations. Evaluations are also, I mean, there's no science as far as I can tell behind it. Each company has their own way of doing it. Some people use KPIs, but they often conflate soft skills. So, for example, you may be asked to write a code which may solve a certain problem, for example, sorting n numbers. And what you output is a piece of code which has implemented this logic. And the test will not be able to distinguish, for instance, whether the problem is in the, not necessarily in the problem is in your understanding of the language, how to write in a particular language, or the logic itself. So that is kind of the biggest challenge in the evaluation landscape, that they conflate reasoning with execution. I mean, we're all like that. When we give exams in classrooms to evaluate students, at the end of the day, we can only see what the student thought through what they're writing. So there is a conflation in these things. There is a lack of standardization, and generally not very clear. What about the AI landscape? Well, AI is being driven by benchmarks to evaluate isolated skills. Some of the publicly known benchmarks which you can look at include things like Big Bench Lite, where there are very clearly defined problems which you can feed to an AI system, and you have an expected output, and then you can evaluate whether the output of the AI system matches with what you were expecting. So I think this is also this dichotomy that we kind of live in. When we come to evaluations for AI, we have like really low level, precise, so clear evaluations, because there is no way to be fuzzy. But when it comes to humans, we have kind of somewhat different ways to evaluate. And if we want to understand what happens when AI joins a team, we need to have a common framework. So the problem with being so precise is that I guess you can only evaluate AI systems in small fragments, so small aspects of their abilities. And I think, as Anand mentioned in his talk, the term jagged intelligence, it really refers to as doing well in some benchmarks and doing not so well in other benchmarks. So at least you start seeing this kind of, behavior. But another thing which actually is quite common and not often reported is the statistical noise, both in terms of the final, the set of experiments that you might have chosen from all possible experiments that you're testing it on, and the performance of these AI tools, which is also statistical. So sometimes people report it, sometimes they don't. So what we did is to basically look at this problem from scratch and try to come up with a mathematical framework which allows, or at least is a first step, to allow us to bring humans, jobs, and AI onto the same playing field where we can talk about assessing job worker fit at a level where um, we can talk concretely about hybrid workers and so on. So in this paper we present like three main contributions. One is a mathematical framework for modeling and measuring worker job fit. And one of the key innovations here is the observation that often when we talk about skills, we conflate what I call decision level and action level soft skills. I already gave you an example of this in terms of coding. So if I ask you to write down a program in Python to sort n numbers, it requires two different abilities as far as I'm concerned. One is the ability to come up with the logical algorithm which will sort n numbers, and then the ability to translate that logic in whatever form your mind comes up with into a precise language such as Python, which can then be executed on a computer. And the reason for us to split this was because based on what we observed, we saw that despite all the progress or claimed progress in AI, where AI seemed to be doing better than humans is in the action level soft skills as opposed to decision level soft skills. Of course, decision level soft skills will vary with the quality of a worker, advanced worker, medium worker, or not so great worker. And in this framework, we are able to associate with each worker something that we call an ability profile. So for a decision level soft skill and an action level soft skill, we introduce a notion of an ability profile. And we also introduce metrics which allow us then to be able to compute the job success probability. So this is our metric of what it means for a worker to be good for a job, how successfully they are able to complete a particular job. And this enables precise and mathematical comparisons between humans, AI systems, and hybrids. So our insights are both theoretical and empirical. Theoretically, we see what is called phase transition phenomena. So phase transition phenomena this comes from physics or math, where we see a sudden change in the phase of something. For example, at around 100 degrees Celsius, water becomes suddenly steam. It doesn't slowly become steam, it suddenly becomes steam. And this is interesting because what it suggests is that for many parameters in this worker job landscape, there can be a sudden shift in success in both directions. If you lose a little bit, you can fall off the cliff. If you gain a little bit, you can suddenly become successful. So this was not obvious. This means that somehow there's a non-linearity, and it also kind of explains, I think, the sudden adoption of AI, at least in the late 2023s, early 2024s. We also look at merging results, where what happens when we combine these workers, and we explain formally the productivity compression idea, which I mentioned in this work of Brian Ofson and also Daron Acemoglu, who's been working on this topic. And then finally, to make all this usable, we create a fully accessible system where you can now use this as per your requirements, if you're a company or whatever. And we empirically show that indeed we identify the regimes where human AI partnership can gain. And these things can then be used by policymakers to inform training, upskilling, and hiring strategies. So I guess the take home from this is that we now have a framework where, if you like, you can make these decisions more analytically. And hopefully this is useful to some of you who are listening here. So let me just skip these slides because I think we are kind of short on time, and let's just go to takeaways. So as far as jobs are concerned, the main observation coming out from this paper is that jobs are layered. Skills need to be subdivided in this world of AI. That's the first and foremost. I do not expect AI tools to become really good anytime in the future, near future, for solving complex logical problems. So if the job consists of solving a problem and then implementing it, we need to break that. We need to break that and try to look at things from a granular, in a granular way. This will help us identify better workers for a specific job who have access to AI system. It also tells us, where we need to invest our skills as humanity. So jobs are not going to disappear. I think they're just going to realign in some sense. The results show that success may not be smooth. It's not like a little upskilling here and there will have a little increment on your ability. There could be sharp thresholds, and it goes both ways. A little downskilling can suddenly make you unemployable. The main message of our work is that AI will have an augmentation effect and not necessarily replacement effect, which is what, at least, when we were writing this paper, there was a much louder and stronger narrative around this. Humans and AI have currently complementary strengths, and I think this is how I see it continuing in the near future. If you're a worker and you're looking for a job, I think you might want to focus more on identifying where you're spending your time on, what you maybe spend more time trying to train to do these decision level skills and not necessarily action level skills. And if you are, let's say, an HR or whatever that measures employees, measure what matters and develop new benchmarks for measuring human workers. And if you're an AI, if you measure AI systems, then focus more on trying to understand more about get more systematically the benchmarks and the noise which I find missing in many evaluations. And I think beyond this, a human AI interaction, in work, this is going to impact many aspects of our existence. How we learn, and more importantly, about our own agency. If you want to read publicly accessible material on this topic, I write. It's all available for free here on my Substack, so you're welcome to join and participate in the conversation. Thank you.
Yeah, thank you so much, Dr. Vishnoi, for your presentation and some of the points on how AI transforming work, learning, and the judgment particularly were very compelling. The ideas that decision level skills are becoming more important than mere execution. And your observation also on this human AI collaboration, the risks of losing foundational skills. And, I've also had the chance to go through the Substack, your intelligence loop, was very impressed and by the essays that you have shared. So, the given that AI is increasingly taking over the action level tasks, so I'm very curious about your perspectives on how educators and organization can help people to continue developing the reasoning and the judgment skills that remains uniquely human, so that the both individuals and institution can thrive as the nature of work evolves. And I would also request Dr. Rao and Dr. Dance, after Professor Vishnu's input, to welcome your thoughts as well into that.
Sorry, could you just repeat your question?
So I'm very curious about your how educators and organization can help people continuing developing the reasoning and the judgment skills. So that remains uniquely human, because as we know that, so that for the both individual level at institutional level, what are the things that thrives as nature of that the work since evolving?
Mhm. So I think, I mean, partly I already answered that, but I'll just repeat that I think educators, which I am one of them, and the other people as well here, we need to kind of reallocate the resources in terms of what we are teaching, what we are evaluating on, which focus more on the judgment, the decision making things, the more complex tasks. And I think most importantly, what it means to being human. I mean, after all, we are human. We experience the world, and these experiences are very, very important. This is what makes us very different from AI. And emphasizing these things increasingly, which I would view as just reallocating in a classroom environment, right? If you were teaching, let's say, a 20 lecture course focused on programming, it could maybe emphasize a bit more on, discussing the logic behind programming as opposed to just getting your commas and colons and brackets right, which is and still is a hard, it used to be a hard job. And also, I think what David said, and I'm sure he will add to it, including things like, what values are we encoding?
Yeah.
So here at Yale, I teach such a course called Algorithms in Society, where this is what we discuss, right? When we reduce a high-level problem to a low-level problem, let's say even something as simple as I want to go from point A to point B, and everybody uses Google Maps or Map or something like that. The solution that comes up is shortest path, but whose values are being encoded in this shortest path and things like that. So I think focusing more on problem solving, ethics, values, judgment becomes important.
Yeah. Dr. Rao, your thoughts?
Yeah, no, great points there by Professor Vishnoy and Danks as well. What I would say for this specific thing, I'll take more the corporate side, why the corporates don't do this. I've asked many corporations, many organizations. Now, everyone has got a good workflow, and we know we are automating the AI workflow. In Dr. Vishnoy's terminology, it is the action level, right? So actions are being executed, right? So work is being done. These are tasks, right? So, and everyone goes around talking about how to automate it, and here's an AI automation and so on. Now, he also brought up decision level skills. I've focused quite a lot on decisions. Now, if you look at what AI is trying to do, it's not just automating tasks, it is making us, it's at least the theory is it's helping us make better decisions. Better decisions than whom, right? So we are the benchmark for better decisions, i.e. humans, right? In every industry, in every sector. So now there is this claim being made by almost everyone that AI will make you obviously efficient in terms of shortening the time, and it'll make us more effective because the decisions are better. Now, there is no baseline, right? So are companies actually logging every decision that someone is making at different levels? Doesn't exist. I often tell the executives, hey, you guys have got transaction logs. Transaction logs have existed in this world for a few hundreds of years, right? So I think the bookkeeping system, double entry bookkeeping system, has existed since the Italian times, right? So I think Middle Ages. Now there's no decision log. How are we going to say that the AI is better than human when you don't even have the basis for the decision log? It's not that, yes, there is a operational challenge of capturing the decision log, but there's a much larger psychological problem with humans not wanting to capture their decisions. If I make a decision and the decision goes well, I made it. If the decision goes bad, hey, I didn't do that decision. The market intervened and the competition did that. The customers changed their mind, all of that. So anything bad is everyone else, anything good is mine. And that's why we don't take the decision. So unless, back to I think what Dr. Vishnu is saying, I think I very much agree that decision level skills need to be there, but even just a decision log where people are actually capturing those decisions, not with a view to finding faults with humans. So that's not the purpose. Even as just a baseline comparison and evaluation, is the AI doing better? In what sense it is better? Do we have those numbers? No. For the large part, no. Right? So there are some instances where there are decisions being encoded. Our judicial system actually encodes all of those, but still the AIs are not very good there. The people are not good, neither is the AI. I mean, again, we can talk for eons about the fairness and the fairness metrics and so on. So it's very tough. Even after you capture the decisions, it's very tough. But my point is we haven't even captured the decisions to even start categorizing. These are simple and these are things that AI can do. So I think that's a huge problem. While we are all massively going on this thing that AI is going to make us more effective, we don't even have a good metric. So I think Dr. Vishnu mentioned is what measure what matters, right? So it is easy to look at tasks. So everyone goes on writing lots and lots of papers as well as doing things around tasks. But decisions, there's no there's no benchmark there for us to actually look at decisions and start comparing it.
Yeah, Dr. Thanks. Yeah.
Well, and I think, and to sort of take these points and sort of bring them back to things having to do with, say, educators. I think one of the keys is not just knowing what the decision was, but how was the decision made. And I think that that's something that we as educators need to be focused on in many ways, is teaching students how to make better decisions in terms of the process. Because if you're making the same decision every single time, it's, oh, this grocery store is at this level of milk, so order more. Like, sorry, AI is going to do that better than a human's going to do it. If it's the same decision, the same process, we know exactly what we need to do, it's going to be able to do it faster, more effectively, more reliably than a human's going to. The value of humans is precisely that we are fantastic, relatively speaking, at adapting to novel circumstances, at recognizing that something has changed in our environment, and so we need to make our decision in a different way or using different factors than we did historically. And that adaptability is what enables us to generalize intelligently, as opposed to what we're seeing with a lot of AI systems that generalize poorly. So, from an educational point of view, that's what I try to emphasize to students is I'm not going to teach you how to do the same thing over and over. Because if that's what you need, an AI is going to do it better. What I'm going to do is try to help you learn how to think creatively, how to think cooperatively, how to think in ways that ask the right questions of the environment in which you find yourself, which AI at the moment really is not doing very well at. If you can give it a well-structured problem where you know what success is, it does better than humans in most cases.
Yeah. Thank you, Dr. Yeah. Yeah. Thank you, Dr. Danks, for your inputs. So, Dr. Danks, you emphasize that, the design choices, whether made by the humans or AI, inevitably embedded some certain values in our technologies. So, as AI takes on more and more active roles in the design, how can organizations make these embedded values into more transparent and intentional? And as Prof. Rao talked about the responsibility, like, the most importantly, who should be the responsible for ensuring that these values align with the human and societal priorities rather than, not narrowing into the optimization goals that AI systems might learn from the data.
I mean, on the values point, I'll say for companies, I guess my view is they already say what their values are. Just too many companies don't think about how those translate into actual operational constraints, how to actually do things differently. Most companies have clear mission statements, clear value statements. They just don't necessarily live up to them. So I think this is, a lot of it is about having a company culture in which it's acceptable to ask why and to challenge decisions, not to challenge them on the grounds of, I don't want to do that, but to say, how does this support the values that we purport to live by? And if your company consistently is saying, well, we're going to overrule that value or we don't care about that, then maybe you shouldn't be declaring to the world that you care about it. I mean, maybe this is a very old-fashioned thing to say, but I think we should hold companies to what they put out there publicly. If you're going to tell me this is a value, show me how you live that in your company. Um, and if you're not going to, then stop claiming that that's an important value. So I think in a lot of ways, that's an important piece. The part that's harder is, of course, those value statements never give you everything you need. There's always going to be specific details of the situation. And there you're into corporate culture. You're into what does it mean to be a BCG employee or to be a PwC employee or a Tata Consulting employee. And every company has corporate culture. There's actually, decades of organizational behavior theorists or researchers who've worked on how to measure it and understand it. And I think that that's one of the big interesting possibilities for the next 2 to 3 years in terms of AI development is can we start to take those insights into corporate culture to have AI systems that are better tuned to the particular corporate culture, not just the publicly declared values and mission, but actually the everyday interactions, which we know how to measure those. It just takes time of anthropologists and sociologists and OB folks looking at companies. But how do we then take those insights from the people studying the people and bring them to bear on the AI systems that we build so that they're supporting the company's values, assuming the company likes their culture?
Yeah, Dr. Rao, the many experts, particularly those with the deep experience and have a longer experience, sometimes push back, against the using of this algorithmic advice, and even when it could clearly help them, they know that they could help, it could help them. So their confidence is in their own expertise often makes them very skeptical of what the system is telling them. So, for managers who are trying to introduce AI, this represents a real cultural challenge. So, from your perspective, what practical steps can managers take to help these experts see AI as a partner rather than a threat? And should this be addressed through, like, training, incentives, team design, or a combination of these? And how can manager, build the trust so that AI adoption feels like a genuine collaboration rather than something is being forced?
Yeah. So I think so my fundamental belief here is we are going at two speeds, right? So the technology is moving at arguably the exponential speed, right? So it's moving very fast. Now, I think it takes time for humans to adapt to the technology. So I think there is also a societal speed at which people are willing to take that adoption. Now, to answer your question, there's almost this, because technology is going at this speed, anyone who doesn't come along at the technology speed needs to be pushed back, right? So there is that kind of narrative going on that, hey, people are lazy or the people don't want to trust the AI and so on, right? So, but I think we as a society should we should not be led by the technology speed. Again, for societal and then broader societal implications, we should take it a little bit slower at the societal speed. Where it gets relevant to trust is not something that can be imposed from top, right? So the CEO says that from now on, everyone will use it and you should trust it. Or we built it in a trustworthy AI way, right? So hundreds of researchers in EU and all around the globe have come up with the trustworthy AI principles and practices. Now, you have built it around the trustworthy AI. Therefore, everyone should trust it. No, I don't care how many other researchers have come up with the trustworthy AI or whatever brilliant researchers have built. I still need to trust the machine, right? So, or the AI. So that takes time, right? So trust has to be engendered, right? So trust has to be earned, not declared, right? So that takes time. So it's not just I think training helps, right? So education helps, but then it is also a process. I think companies have to go through. So to me, it's not the change management is a sort of a well-known discipline now, right? So it wasn't when early on, when computers were coming in and there were lots of changes, people are obviously scared. I think we are in another one of those points, inflection points, where I think trust management needs to be taken seriously, where we are talking about trust between the person and the AI, a group, and how they let multiple AIs work within their group and within their organization, which should encompass all of the things that Professor Danks has been talking about, right? So David has been talking about as to what is the value? What is the value of the individual? What's the value of the company? And when we operate within the company, we bring in both values, right? So people determine the company value. The company values are imbibed by the people. It happens both ways, right? So how does that happen? Now, to some extent, OpenAI and some of the others are actually capturing the way we interact with the system as the kind of values, right? So it's not quite the values, but they are keeping that in memory, and there is sort of something that is sort of coming there, but that's something that's still not under our control, not under our view. There's nothing like a corporate value yet, but they're trying to capture that individual. Maybe they'll definitely go into the corporate side, but it's still a long process there. And I think we shouldn't be pushed into a speed that the technology folks want us to, and all the investing community wants us to. So we should take it at more the human societal speed.
Yeah. Dr. Vishnu, your thoughts?
I mean, I agree with Professor Anand Rao here on trust. I think that and values also, right? So I'll just add to it that I mean, as we are interacting with these systems, new values are being formed. I mean, that's always happening. Whenever we are in this ecosystem and the ecosystem is changing, can you hear me?
Yeah, we can hear you. Yeah.
Yeah, so new values are being formed, and there is a complex negotiation in these things, right? So it's not as simple because, you know, I mean, corporations are driven in a top-down manner, and so naturally, trust. Well, whereas as Professor Rao said, that trust usually builds from, you know, bottom to top. So this conflict, I mean, is very much present, and I think needs to be studied first, I would say, before we can figure out how this can be resolved. I mean, I'm not an expert, but this is not a unique situation. I mean, the concept, I mean, the idea of, you know, values is not at all specific to AI. You know, even if, for example, you know, MIT math department, you know, for until I think late 1990s did not have a bathroom for women. Now, you know, this is, so who designed the building, you know, whose values are being incorporated, clearly it tells you a lot about it. So, you know, we are surrounded by these systems where values are being imposed on us, trust is being required on us, required from us, and you know, it's very hard. I mean, I actually do not have any answers to that. You know, and then there is this kind of unholy marriage of corporations and politics, which is happening worldwide, right? Uh, and people being controlled through data surveillance and so on. So this is going to be an increasingly complex problem. I appreciate my colleagues thinking about it, but I don't have any answers. I'll just say that values are changing organically and inorganically, which we also need to take into account while thinking about these broader issues.
Yeah, Dr. Danks, your thoughts?
Yes to all of that. I mean, I think it's, the I think especially I wanted to pick up on something that Professor Vishnu said there at the end, which is the inorganic changing of values, which is to say the changing of values that comes through governance, through regulation, through law, through policy, whether internal to a company or in a country. And, I mean, we've seen, I think, in the last 9 to 12 months, a significant pullback by a lot of governments in terms of their interest and efforts to regulate and govern AI and to shape the values that govern AI. Use governance to shape the values in AI. I think what's been interesting has been to see some parts of the technology sector actually stepping forward and saying, okay, if government's not going to do it, we're going to make the case that, as some preliminary work that's coming out of IBM research is suggesting that, you know what, we think that responsible AI has ethical AI, that this has a positive return on investment. So we're going to make that part of our hallmark. We're going to make it something that we're going to use as part of our branding. And so it's sort of what we thought might be a path to changing some things about technology, namely the inorganic imposition of certain values by governments, has actually morphed into a much more organic process by which some companies and, of course, therefore also some students are realizing that there might be a path forward if they're willing to commit to more responsible, ethical, human-centered AI design and development.
Yeah, so Professor, we are running out of time, and we'll be just stretching this discussion for 5 more minutes and taking few audience questions. So there's a one question by Ajit Paul, and he's telling that is the AI black box effect uh, system increasingly the problems of the ethic gaps and also complicating maybe ethics and development silos of the AI programming. So yeah, Professor Dance, if you would like to take this, yeah.
Yes, this is the short answer. Black box systems, by their very design, we don't exactly know how they're working. And so therefore it's hard to know when they're going to behave ethically or responsibly. It makes it very challenging, I think, for people to use these systems in responsible ways. That being said, I think we do need to be careful that it's actually, I think, not so much there's nothing intrinsically problematic about using a black box approach. I mean, there's all kinds of medicines that are essentially black boxes. We don't really know why they work, but we have done so much rigorous testing and evaluation of the medicines that we're happy to use them. And we know in these cases it's fine to use them. So I think being a black box makes it much harder to use systems ethically, but it doesn't make it impossible. And so, the reality is large scale AI systems are always going to have at least some black box element to them. Any sufficiently complex system, we have to treat parts of it as black boxes. So I think it's important not to think that there's this sort of necessary choice we face. Either we get good performance or we can use things ethically. I think it's, the ethical and effective they're not antonyms, they're not opposites. And we need to make sure to bring that message to folks building black box and testing black box models as well.
Yeah, Dr. Vishnu, your thoughts?
Yeah, I agree with Professor Danks. That this is a false dichotomy, being ethical and being useful. In fact, several of my works have shown mathematically that things like diversity, fairness, etc., can increase utilities. And the reason for that is many of these companies which are optimizing and presenting or developing AI systems, um, they are also taking their decisions based on data, right? Which market segment to focus on, what should be the strategy and so on. And this data itself may be biased. So if you are so mathematically, let's say if you are optimizing something based on a model which is not necessarily accurate, you are not going to go to an optimal solution, even if your goal was to maximize profit. So even in that very narrow world of maximizing an objective or profits, uh, often it's there is value in bringing in these things because that just broadens. And there are studies done. I mean, I don't want to take up too much time on that, but yeah. So I would kind of definitely echo what Professor Danks and Professor Rao have been saying.
Yeah, Dr. Rao, I have one question for you from Sai Meher. And he wrote about like with AI entering into product teams and operationalizing tasks that are easily decomposable and closed loop. So how should top management approach this aspect of organization restructuring without creating chaos while trying to create a flatter organization?
Yeah. So this is where I think there's a trade-off here, right? So if you go, AI has the potential to actually flatten many of the organizations, right? So now the way the organizations, the business units, and the functional units emerged is more as a result of what is optimal from a human perspective to do within a group versus communicate from one to the other, right? So if it's entirely flat and everyone is trying to do everything and trying to reach everyone, I think we'll just overwhelmed with the communication. That's why the silos or the boundaries were set up, right? So now AI can destroy some of that, most of it, all of it, whatever way you want to look at it. But do we want to go in one flat swoop, going from a very hierarchical organization to a complete flat? Yes, there's probably, depending on the task that you're doing, if it is sort of very mechanical, repetitive type of task, you probably can do that to release quite a lot of shareholder value. But do you really want to do that, or should you be really doing that, right? So, or is there a path which is a slower path but less disruptive, societally less disruptive path? I think that's the kind of debate at least we need to have, right? So as opposed to being led to, it is obviously better, so let's just do it, right? So, and release the cash to the shareholders, right? So yes, instead of releasing, let's say 100 million to the shareholders, can you release 70 million and keep the other 30 million to retrain the people, re-educate the people, reskill the people, or get different kind of people? So try and do some kind of a trade-off, and that discussion is not happening. If there is an efficiency, let's just go and get it. Don't worry about it, they'll find something. And then there's this usual economic theory that, hey, eventually we'll create more jobs than it is. Yes, eventually we will create more jobs, but what about the current people who are losing those jobs, right? How do we handle those, right? So eventually everyone will be dead, as they say in economics, right? So we're not worried about that situation. So what happens now, especially with the dispossessed group, I think is where I would go.
Yeah, so we are overshooting a time, and so unfortunately, we will not be able to take any more questions. And as there are very interesting questions in the chat box, I can see. So again, a very big thank you to all our speakers and our audience for being such an engaged and thoughtful group today. Our panel, When AI Joins the Product Team, who really drives innovation, gave us a lot of reflect on about the role of AI in shaping work, strategy, and the human judgment. Dr. Rao took us into the strategy part, where showing how AI can simulate hundreds of thousands of scenarios to inform decisions, create strategic flywheels, and accelerate learning. Dr. Vishnoi helped us to understand how AI is transforming the work, learning, and the decision making. And yes, Dr. David Danks challenged us to think about how AI is not just a tool, but as a designer that embeds the values into technology. So so once again, thank you to the all speakers, and may I now request Mr. Venkatesh to formally close this webinar?
Thank you so much, Professor. Thank you, Shivam. And it was a wonderful session. And on a Friday evening, you would have noticed that we had more than 130 participants for the most part of the session. And we could also see some of the senior professors from IIM Bangalore joining. We have had Professor Shankar Venkatagiri, who is the chair of Information Systems area, who joined, and Professor Rishi, our ex-director, has already requested for the recording. Hopefully, with your permission, we can share the recording with our professors and researchers also. And another point that we thought it would be worth making is we have our upcoming software product management summit, and after looking at the recordings, I'm sure there are going to be some requests for inputs from you professors that can enrich our software product management summit, which is about 6 months away from now. Hopefully, you wouldn't mind getting some mails or questions where you could give your inputs. So maybe assume that you are okay with.
Yeah, I'm fine with it. Yeah, very
Okay.
happy to.
Okay.
Yes,
Yeah,
happy.
Yeah.
Thank you. Thank you on behalf of Professor Mayank Kumar, who is the chair of Center for Software and IT Management and the center. Thank you again very much. And all the participants, thank you all for staying back this late on a Friday evening.